right. Can I just quickly get a hand up as well that you can hear me? Someone? Yeah, happy days. All right, my name's Nathan. I'm a sales engineer at Datadog. I'll be running you through today's session around cloud cost optimization. Just for the record, this isn't a demonstration session. I'm not actually showcasing Datadog. What I'm showcasing today are the principles that Datadog's engineering org, which is several thousand engineers strong, how we adopt practices to try and optimize our own IT costs, right? So while I will use Datadog as, you'll see a couple of screenshots, the reality is you can use these principles with pretty much any observability platform, but one of the prereqs here is that you do have observability. So you do have some level of tracing, some level of infrastructure monitoring, whether it's CloudWatch, whether it's open source, whatever it is, you should be able to apply these principles to your stack as well. So just a bit of context setting. For those of you who don't know what we do, we are an observability platform. We ingest your traces, so let's see if I can do this. We ingest your traces across your different microservices, down to the database layers, and we ingest your infrastructure metrics, we ingest your logs, and put it all for you in a nicely framed picture. But the reality is we do this for 26,000+ organizations globally. We are fully SaaS-based. We're primarily on AWS, and with that said, we are processing tens of trillions of data points per day. So when we're talking scale, we're talking big scale. Over 10,000 Kubernetes nodes is what runs Datadog. And this comes with certain challenges. So us as an engineering organization, we were trying to work out how to make this run more efficiently. And I'll run you through those sort of key findings that we took away from it shortly. But we're going to run with a bit of an analogy today, which is a Toyota Prius and a rocket ship. And we're going to posit that you should be like a rocket ship. And it's not because you need to go to the moon. We're not crypto bros or anything like that. The purpose of this is that it's all by engineering with intent, right? It's about making sure that, okay, this is the business process that we are engineering to solve, because the engineering solves the business challenge, not the other way around. The business isn't here to drive the tech is here to drive the business. And it's all about design with intent. In terms of this Toyota Prius and the rocket ship, there are some similarities, obviously. They're both white, I guess, aesthetically. The reality is, though, they have very different fuel consumption figures. So if we're thinking about efficiency, lots of people think in terms of transport, hybrid car, 4 liters per 100 kilometers of distance covered, whereas a spaceship, this one I think was about 650,000 tons of fuel for traveling 35,000 kilometers. So realistically, efficiency might be, as a definition, a bit misleading here, but it's about by mapping it to the business process that you're trying to solve. And we'll come back to this analogy throughout the presentation. But let's jump into the 3 main considerations Datadog had here. The first is traditional FinOps. There's nothing too crazy here, but we do need to cover it because it's a requirement. Remove the unnecessary. So removing orphaned instances, making sure that we're not paying for resources that we're not using. We'll get into a bit more detail here. Prioritizing effectiveness and efficiency, because lots of organizations we found tend to stop at removing the unnecessary, and i.e. traditional FinOps, but it needs to be sort of prioritized, and there needs to be a framework that covers all of this as well. In that effectiveness here is defined by the business process that we're trying to solve, and efficiency then falls in the engineering category underneath, where we are trying to make sure that are we using our resources in the cloud optimally. And then finally is the sort of human element to all of this, which is shaping our culture to reinforce these changes, because otherwise the first 2 steps can be kind of ad hoc processes. The FinOps team will send a report to the engineering team, who then need to chase it up and downsize, remove resources, whatever it is. But this needs to be an ongoing process. There needs to be a sense of ownership across all the teams. So let's jump into removing the unnecessary. To jump back to the hybrid sort of explanation, when we look at the car, it has certain elements in it that are designed to make it efficient in some sense. So the GPS, for example, sometimes an optional extra, but nowadays mostly standard. It will help you get from point A to point B efficiently. It will pick the route that's the shortest or the fastest, avoiding traffic. That is an obvious win, despite its extra weight consideration to the vehicle, which will obviously reduce fuel efficiency. However, there's other includes, for example, that are often standard that actually you might not necessarily want. Air conditioning, a big sound system, neither of those actually help you get from point A to point B. Similarly, for optional extras like a sunroof, okay, yeah, it might be nice to open the sunroof up, but that's going to ruin the aerodynamics of the car. It's also going to ruin some of the structural integrity of the car and add to weight. So you're not actually getting from point A to point B more efficiently. The Rocket, on the other hand, is definitely not that. It doesn't have unnecessary windows, doesn't have an unnecessarily big sound system. It has a minimum viable requirement to get you from point A to point B. And that's what your IT systems should be aiming towards, effectively. So how do you actually do that? And effectively, where you should start is look at consolidating tool sets. So us as a very large observability vendor, we do it for 20,000+ organizations. We regularly encounter a dozen, 24 different tool sets used for observability, for example. And that causes issues in two senses. First of all, when you have a service incident, a P1, P2, you get the war room together. Well, if you've got 12 different tools, you probably have 12 different SMEs that all need to be brought into the war room. And then that increases your MTTR because they need to communicate with each other. Hey, is it in your section? Is it talking to this particular point? And that creates a bad engineering experience. It increases your churn of engineers as well as increasing your MTTR, which hits your bottom line. And secondly as well, you now have, if you're all using proprietary vendors, for example, that's 12 different contracts you now have to negotiate and own. So it's the business side of it as well. That's 12 contracts your legal team have to review. That's 12 contracts your procurement team have to manage. It's 12 different negotiations, whereas if you have, let's say you consolidate down to a handful, well, you have now better buying capacity, so your price is going to be better when you negotiate with the vendors as well. And one of the challenges we see that organizations have is they are too willing to necessarily add another tool to the belt because they want the fanciest and the cutting edge, which is great. But on the other hand, you do want to evaluate whether any of the existing tools are actually going to solve that use case. As organizations are going and gravitating to the cloud and maturing and breaking down monoliths into microservices architectures, you don't necessarily need to add another tool. Make sure you're asking the question, do any of the existing tool sets cover what we already need, what we're going to need with this re-architecture? Secondly, eliminating unused resources. This one's pretty self-explanatory, but what we find is engineers are really good at removing the compute component of resources when they're going through development phases, like the EC2 instances, the Lambdas. They're not particularly good when it comes to removing, for example, the API gateways and the load balancers and the S3 buckets that were attached to these compute resources. And these just slowly amass, and then all of a sudden you're paying for hundreds upon hundreds of resources that you're not actually getting any value out of. So make sure your tool set is going to highlight these orphaned instances or resources, your RDS instances that are not connected to anything, your S3 buckets that are just used as data stores because you might need that data, but in reality 99% of the time you don't. Put those in Glacier storage. Put in a process that if it's not being actioned or touched within 7 days or whatever it is, let's put that in a better storage tier so we're not paying unnecessary fees. And similarly to that, make sure you're automatically scaling downwards as well. The reality is, one of the benefits of being in AWS is being able to scale very rapidly, so that the business process that we are supporting is actually going to be consistent in its efficacy. However, make sure that there's a process to also evaluate, hey, is it CPU usage, memory usage, it's a number of requests, whatever it is that's going to make sense in this context, has that dropped? And if it's dropped, let's make sure that we are also going to automatically scale down our services so that, again, we're not just paying unnecessary fees without getting any value out of it. And one of the low-hanging fruits here would be something like your dev and test environments. If your engineering teams are based in Australia, it's very likely they're not going to be using the dev and test environments 24/7. Shut them down for 12 hours a night, 8 hours a night, whatever it is. That's going to halve your dev and testing environment costs, and that's low-hanging fruit. It doesn't actually take much to action that. And similarly, you can shut it down on weekends and save some costs there as well. And with these ephemeral environments, consider also using something serverless. Serverless in AWS is very popular, but nevertheless, there are other use cases that you can utilize in ephemeral environments because it's ultimately, action-based, execution-based, whether it's time-based or invocation-based. That will help you, in effect, automatically downscale without needing to set up anything on your end. The second key step in reducing our IT costs is around prioritizing effectiveness and efficiency. And these are delineated. So to break it down back to the Prius and the rocket ship, the Prius gives you two figures around fuel consumption. One of them is around city consumption, one of them is around highway consumption. And the reason is because they don't know where you're going to be driving from. They need to meet the market and cover a whole host of different use cases. Whereas the rocket, well, there's a very defined trajectory that it needs to take. It needs to get from point A to point B, maybe to point C, carrying a specific payload that weighs this amount of mass and needs to arrive at this point in time. It's a very binary outcome whether you achieve it or not. And that is similar to your services in the sense that you should be aligning these outcomes with the business process that is underlying it and setting service level objectives around the outcomes of this. So you allocate, for example, 2 nines, 3 nines, whatever your allocation is, a budget spend of failed delivery of these business metrics, and make sure you're measuring that and improving that. And that should basically be prioritized above all. So we have a whole blog series on service level objectives. You can Google Datadog service level objectives. I'm not going to go through it today because it's going to take probably another hour, but you can quickly Google that and find it yourself, or come chat to us at the booth afterwards. But when we look at the rocket, the center of this is now orange. The original version of this rocket was actually white. And the reason why they removed white became a different color is because they realized that that's the main storage compartment of fuel. They don't need to protect any electronics inside, which is what that white paint is doing. But in the first iteration of the rocket, they prioritized effectiveness, i.e. accomplishing the mission of delivering the satellites above all. And then in the iterations afterwards, that's when they started prioritizing efficiency and working out where they can make cost savings. And again, this is exactly the same with what you can do with your services. So this is where your observability platform really comes into play, because you can start deep diving the metrics with your tracing, with your profiling, and that's exactly what we did in Datadog. So we identified which API endpoints through tracing were actually giving us issue, which ones were being hit the most regularly, which ones were taking the most amount of latency, working out the bottlenecks. Was it database layer? Was it a different microservice that's downstream? That's what tracing is for. And then from there, once we identified the endpoints, we then dug into the code level to understand which methods, which functions actually are the ones that are giving us trouble. Because profiling will give you CPU usage, memory usage, heap dumps, all those metrics from the language itself to then allow you to work out where the bottlenecks are. And it might not be your code. It might be a third-party library that you have used as one of the default libraries, which is exactly what happened with us. We found, we use Go heavily in our backend services. The default JSON logger is really intensive in resources. We changed it to be a different formatted one that we built, and that reduced our CPU usage by 60% and memory usage by 50%, and that led to us saving $400,000, just like that. And we wouldn't have found that out if we didn't embrace experimentation. So giving the engineering team scope to actually test things, build things. We also allowed them, one of the tests we did recently was testing ARM-based Kubernetes nodes, and that saved us over $1 million in a few months. So allowing the engineering team to actually jump into these platforms, understand the metrics, give them ownership of it, and give them some scope, give them some hours in a sprint to be able to jump in and test some ideas. Don't get me wrong, we fail with most of our experimentations. That's just the nature of engineering. But importantly, we have some big wins, and it's hard to argue with $1 million savings. Finally, building a culture of ownership. Now, this is the human element. As I said earlier on, the first two steps, the categories, they kind of can be seen as ad hoc. You really need a repetitive process where you're coming back and revisiting all this information. And that's where having a siloed team of FinOps and engineering becomes problematic. So if you look at, for example, the Toyota Prius, There is a monitoring team now because IoT connects everything. There is a monitoring team monitoring the efficiency of your hybrid vehicles, your electric vehicles, whatever. But they're not going to reach out to tell you that something's wrong. They don't care. Whereas the Rocket has its own dedicated platform of teams that are monitoring it, and if they see anything anomalous, it doesn't matter if it's not within the scope of what they are trained in, you can damn well bet that they're going to point it out because they're being proactive, they care about the end-to-end relationship of the mission. And again, that's what you should be adopting for your services as well. This idea of end-to-end service ownership by reducing barriers between your observability tool sets. So it's also accomplished by the previous points made around tool consolidation, for example, because if they can't access the observability data in another tool set, well then they can't really take ownership of it, can they? So you need to make sure that you're breaking down the barriers where possible. And FinOps, similarly, bring that information to the engineering team. So what we did in Datadog is we added a few tags in AWS. Tagging is really important in AWS as it is in Datadog for that matter, but we inherit those tags from AWS through our integrations. And for the record, we also use Datadog to monitor Datadog. So a lot of the development work that we actually put into our platform is driven by our own requirements as much as it is by customers. We are our own biggest customer. So we shape effectively how our product looks. And adding a team tag so that we can quickly understand, for example, what service is owned by whom. Who do I need to reach out to contact to say, hey, your upstream service is making a lot of requests to my microservice. Why is that the case? And also adding a service tag to the resources in AWS as well. So what we have is a service catalog in Datadog. It's, as the name implies, it's a list of all our services. But there are different tabs. So the engineering team primarily lives out of the performance tab and reliability tabs. But we can obviously see that there's a cost tab, which we've added recently. And that pulls information from the cost and usage reports in AWS and looks at the tags that are on those AWS resources and allows the service owners, i.e. the engineering team, to see that, oh, the cost has actually increased. And engineers are curious folk. That's why we're engineers. We like to make things better, and that's just our innate behavior. So giving them access to this information makes it much more closer to them in the sense that they can spot nuances much more quickly than a FinOps team doing a weekly or monthly review are likely to find. So they're much more likely to action it faster, which has a snowball effect on efficiency improvements and ultimately your cloud cost savings. So make sure that there are elements of the cloud costs that you're spending, or any other costs for that matter, being brought to the engineering teams themselves, because then they can actually take ownership of it and make the improvements necessary. Being product-oriented is important in the sense that they need to be able to understand the bigger picture. I've mentioned it throughout this presentation. They need to understand what is the business problem that we are solving, because engineers, we tend to get fairly stuck down in the technical details and want to improve things. However, we sometimes lose sight of what the business process is that we're actually supporting and what the context is that our particular service sits within. So making sure that they understand the broader picture so that they can take that into account when they're actually going ahead and making any changes. And finally on this point, celebrating wins. So we have a Slack channel in Datadog. It's called Performance Wins, and it's exactly as the name implies. But importantly here, it's not just sharing when we've made improvements, it's also got executive buy-in. So most people don't know what our CEO looks like because he has a pretty hidden persona in some senses. But that's our CEO. And he's actively watching it, and so is our CTO. They're both engineers. And they actively watch this channel, chime in, and that is social validation. Engineers want validation as much as anybody else. It creates buy-in, and it creates more formality around the process as well, because these should be celebrated. And it reinforces this whole culture and allows it to become a cyclical effect, where, oh, I want some social validation. It'd be great. What efficiencies can I perhaps find with the time that I have to experiment in our services, for example? So to recap, 3 categories: remove the unnecessary, tool consolidation, Make sure you're not adding extra tools unnecessarily, and make sure that you are, where possible, making your observability more manageable and more efficient, so you're reducing the MTTR. Deleting unused resources goes without saying. Make sure your toolset can do that. And automatically downscaling. Prioritizing effectiveness and efficiency. Effectiveness here being aligned with the business process before targeting the engineering efficiency. It will also increase the cadence of which your innovation can occur as well, because you're more focused on solving the business challenge and adding value to whatever your service is doing, rather than getting into the nitty-gritty of writing a new JSON log library. Because that might not have actually been a bottleneck for us, but we wouldn't have known if we hadn't done the business process solution in the first place. And then finally, building a culture of ownership. Make this a cycle. Bring the teams close together. I hate saying it because it's a marketing term, but shift left, breaking down the silos, all of that stuff, it's repeated over and over, but this is in effect what it is in practice. Make sure that the teams can actually interact with each other, see each other's data, and then they can actually cooperate as teams and work together as one. That is me. I don't actually have much else, but I didn't go through a demo of Datadog. That wasn't the plan today. But if you guys have any question around our platform, we're in a booth. We're like 50, not even 50 meters that way. I can see the booth from here. Feel free to grab me. I'll be at the booth after the session. But thank you. Thanks for your attention.